Today we will discuss the database architecture in three different ways. In the process, we'll discuss the three schema architecture and how this three schema architecture is designed to give data independence. Then after that, we'll also discuss the the centralized and the client server architecture, how database architecture evolved from a centralized database system to a client server architecture. Now, to begin with, let us pick up this three schema architecture. What you see in front of you, the diagram that you see in front of you, is the diagram taken from the book Al-Masri and Nawad Fundamentals of Database System. All right. So this we will use to illustrate how this three schema architecture works. Now, the important characteristics of database approach. One thing is that we want insulation of programs and data that we have briefly discussed in the previous classes, that there should be independence between data and program. That when you change the program, when you change the data, that program should not be affected. Similarly, we also mentioned about program operation independence. You can bring in different operations or reuse operations which are meant for other programs, but whenever you are changing the program or you're changing the operations, that these two should not disturb each other. And the other thing is that in the characteristics of database approach, we also mentioned multi-user views, that user view there should be multiple views for the users. And then the other characteristic is that the use of a catalog to store the description of the database system, which we also call it schema, or in other words, the schema of the database system or the design of the database system is stored in a catalog, which is also, the catalog is also known as metadata. Now, in order to support or allow all of these characteristics that we have mentioned, it is necessary to have an architecture that supports, that allows this kind of independence or this kind of functionalities or characteristics of the database system. So one illustration is that this three schema architecture, in which we can illustrate how these things can be achieved. Now, this three schema architecture is a proposal that will, that will help us to visualize how the main characteristics of the database system can be achieved. Now, the goal of this three schema architecture is to separate the user application and the physical database system. That means there are multiple applications. So one is users, applications, and the database itself. So one objective is to separate this. Now, if you look at this diagram, we have the internal levels. Okay, here, internal levels, and this internal level has an internal schema. This is the internal schema. That is the internal design. So these internal designs describe the physical structure of the database, how the data will be stored, how it will be retrieved, how it can be accessed, what is the access part, and all of those things are stored. Are kept here, described in the internal schema or the internal design. Now, we also have another one, which is conceptual level. Now, the conceptual level has a conceptual schema. The corresponding design is a conceptual schema. So these describe the structure of the whole of the database community of users. This conceptual database is concerned about the community of users. Now, what this also conceptual schema also does is that we have been saying about hiding details, right? Hide details, because when you see something and then too much in detail, then you are unable to do the specific things that you want to do, because if the detail is too much, then you get overwhelmed with the details. So in order to avoid that kind of thing, the conceptual schema hides the details and display only the relevant portion of the database or the relevant part of subsystem of database to the users. Now, this concentrates on the describing entities. The conceptual schema will describe entities, data types, relationships, user operations, and constraints, which are very much important to how a user will conceptualize the database system. So it's also a user, often they use representational data models to describe this conceptual schema, and not necessarily that they have to use it, but that is what is supposed to be the appropriate data model. Then we have the external or view level. This is the external or the view level. Now, it includes a number of external schema. Here we didn't put the schema, but there will be multiple number of this one, external schema, or in other words, external views. That means, as we have said, that the users can or should be allowed to view the database system in multiple ways. So here, its schema describes the part of the database. I mean, its view or its schema describes one part of the database system, and then that one part is focused on giving access or giving a view to one group of users who are interested in that particular view. As I've always said, suppose this is the database system, right? Then how many we have one view, we have another view, we have another view here. So we have, in this case, we have just given as an example 3 different views. So the external view will not be limited to 3 different views, of course, but there will be multiple views. So each user, this A group of users are interested in A view only. C group of users are interested in C views. Therefore, accordingly, C schema or the C external view is a schema that provides view for this group of users. Similarly, B also. So we can have multiple views. And then the rest of the details about the database system is kept hidden. So in its external schema is typically implemented using some representational data models. Now, the tree schema, this schema architecture is a very convenient tool, at least to visualize how the database will look like or how the database ought to be, right? But you have to remember that most database system, okay, most database management system do not necessarily follow this 3 schema architecture, but it more or less in totality, okay, but it more or less support how we visualize or how we conceptualize the 3 schema architecture, okay. Now, some database management system includes the physical details, For example, the internal schema and this and these two sometimes are combined together, or I mean, which means that this and this are not a separate level, only they are grouped together, and the external view is a separate level. Similarly, different ways of I mean, doing is there. I mean, separation is there. Yeah. Now, external schemas are specified in the same data models that describe the conceptual information and so on. If you notice that the three schemas are only a description of data, okay? Only data that actually exists in the physical is at the physical storage. Now, this, okay, if you look at the bottom, this is where the actual data is stored. The internal schema, the conceptual schema, and external views are simply different layers or different levels of description of the data. So its user group, as we have mentioned here, its user group refers to only its own external schema. So the database management system must transform what the users, what the end users are requesting. At every stage, they have to transform, okay? Transform the user's request into something that the users can see. For example, a request specified on the external schema here, whatever request is mentioned in the external schema has to be transformed against the request into the conceptual schema and then in the internal schema. So you are requesting a particular view, a particular access to a database system. That request will be changed into conceptual schema, then internal schema, then ultimately it will be retrieved from the system where the actual database resides. Now, this if the request is a database retriever, for example, the data extract from the stored database. Okay, this is where we are storing the actual database. So if it is a retrieval request, then from the store, it has to be reformatted to the external views, the user's external views. Okay, so the process of transforming requests between levels are called, what we call it, mapping. Okay. So a request which is being in this schema architecture, the request which is being made by the made by the users through the external schema, ultimately will be, like if it is a retrieval, then it will be retrieved. Then when from the internal schema, conceptual and then internal mapping, that is transformation of the request into conceptual schema, into external conceptual mapping, which will be converted into external views and so on. So that up and down process of mapping is there. So this transformation is what we call it mapping. Okay. Now, a certain amount of mapping is necessary to transform requests. And usually what happens is that when we are doing mapping, it often takes time. So that is why not many users or not many database, the actual database management system have, I mean, that so they try to avoid too much of mapping because it, I mean, it requires a lot of time in order to have multiple mapping. In order to I mean, make the retrieval access faster, people often do away with some of the mapping and then try to make the access as fast as possible. Now, with the help of this, we can achieve some data independence. That is why I'm using the same figure to explain what is database independence. So in database independence, we have basically we will use this tree schema architecture to explain the concept of data independence. So we have two types of database independence. One is the logical data independence. Okay. And we have the physical data independence. So we have two types of independence. Now, logical data independence is the capacity to change the conceptual schema without having to change the external schema. Logical independence means that we set the schema here, okay, when you want a change, like we said in the previous classes, that the stored database will keep on changing. These are highly dynamic, but the schemas are not supposed to change very often. But we also said that there is such a thing as schema evolution, if you remember. Okay, schema evolution. So in schema evolution means that in due course of time, there will be a necessity to make some changes in the design or the schema. So when such designs takes place, for example, you can make a changes in the conceptual schema, but in normal programming language, what happens is that whenever you make a change here, you will also require a change here. Okay, but in this case, we are saying that the three schema architecture, I mean, if you have a separation of this architecture like this manner, then you will have a logical data independence. That is, you change the conceptual schema without having to change the external schema. So why would we need to change? We may like to change the conceptual schema to expand the database by adding some record type. For example, we have students' roll number, name, age, and later on we realize that we should also have gender. So there is a later addition, right? So like that, we may need that kind of change. So what happened is that to change constraint, or we may like to change the constraint. Some constraint may be modified, or that is some rules may be modified, or to reduce the database by deleting some record type. Maybe we don't need gender and we delete it, for example. So what happened is that we only in external schema that refers only to the remaining database should not be affected in case if it is deletion of the record type. Okay, so that is what is logical data independence. Now, when it comes to physical data independence, this is the capacity to change the internal schema. Okay, change the internal schema without the necessity to change the conceptual schema here. Okay, so without disturbing the conceptual schema, which is, as I said, in conventional programming, which, I mean, if you change something here, you need to change change here as well. But in this database schema, I mean, in the physical data independence means you may make changes in the internal schema without making change in the conceptual schema. So the external schema need not be changed. Change to the internal schema may be needed to, because some physical files may be reorganized. For example, that the file that we are keeping, we want to reorganize, we want to make more efficient the access part, some modifications required, then there may be change may be necessary. So this is the two data independence that we are talking about. So these are the logical data independence and physical data independence. Now, DBMS use additional software to accomplish mappings. For example, we said about mappings. Okay. Now, by referring to the mapping information in the catalog. So when data independence occurs, because when the schema is changed at some level, the schema at the next level remains unchanged. Only the mapping will change. Okay. Only this mapping will change. In this case, it will be here. Okay. Because the mapping takes care of how it is converted into different views. So you may make the changes here, addition, deletion, expansion, modification, you may do all of those things. But you don't make the changes, rather you simply make the changes in the mapping. That means, suppose some portion of the internal schema has been deleted, then the mapping has to be changed. That is the only change that is necessary. Okay, so this logical data independence, physical data independence is possible, but as we do it, we may still make some changes, and that changes is only changing and the how the mapping is done between the conceptual and internal mapping and external and conceptual mapping. So in a way, this database, I mean, the tree schema architecture not only explains how the database is organized, the architecture of database is done, or maybe I mean, written in the actual database system, but it also helps us understand how data independence can be achieved. Okay, now let us come to the client server architecture. I mean, centralized or client server architecture for database management system. Okay. Sorry. All right. Now, first thing is that centralized DBMS. We have done this little bit in the beginning of the course. Now, centralized architectures have our centralized database system. Okay, as I said in the previous classes, that database systems follow what? They follow the evolution or the trends in computer system architecture. Okay, it follows the computer change in computer architecture. So as the computer architecture is changing or evolving, then the database system also follows. As we said, computers used to be mainframe computers, okay, where we have everything is concentrated in this mainframe system. Then if these mainframes, as computers become smaller and more powerful and more affordable, then we started having smaller computers which are interconnected. Okay, so this becomes this is how I mean, in a very short capsule, how from mainframe we are moving to the network system. In the network system, you have smaller computers, but these smaller computers are much more powerful than the mainframe computers. So this is how the computer architecture evolves. Similarly, database system also evolved from a centralized system where you have all the modules, all the processing capacity concentrate in one centralized database system. And eventually, some of the processing capacity, as we started moving to client server architecture or a network-based architecture, then the processing is also no longer concentrated on a single computer. Rather, it is being distributed. Okay, so this is how the the database system evolved from a centralized database system to a client server database system. Now, this is possible because as the price of hardware comes down, most users replace, initially what happened is that you have a mainframe computer, and then these mainframe computers are connected to terminals, okay, are connected to terminals. Now, what happened is that only this one, the server, is capable to process. The processing capacity is concentrated in the server. These are simply terminals. Okay, they use these terminals which has very limited capacity, limited processing capacity. Okay. Now, similarly, what happened is that it only these terminals are, in other words, sometimes they call it dummy terminals also, because what it does is it only displays what the server is doing. It has no local processing capacity. These computers do not have that kind of power or processing capacity. All processing capacity is concentrated on the server. The servers are usually a computer with more processing capacity, okay, more storage capacity, more of everything. So every request or every processing to the database system is done in the server, and the user's interface or the terminal simply display what is being done there. So they have no processing capacity. But as time goes on, this user terminal, which is mostly dummy terminals, which has no processing capacity, is eventually replaced with more powerful personal computers and workstations. Okay, we don't use these things that much anymore, but these are supposed to be computers which are more powerful. That means that these terminals have the capacity, some processing capacity. So some part of the DBMS processing is moved towards the user interface, user terminal, which is now having some processing capacity. That means the processing capacity is enhanced. It becomes much more, it's no longer limited. Okay, it becomes much more powerful. So some processing of the database system is moved towards the client. That is how we have the client server architecture. So what happens is that instead of everything concentrated here, okay, so some portion, for example, A, B, is moved towards the client side. That means they will be able to do A and B. They will be able to perform the processing of A and B. I don't want to be very specific because at this juncture you are not familiar with many terminologies. So it has so many, this server may have A, B, C, D, E, F, A, but out of all those modules, some modules may be moved to the client sites. That is how we have a client server architecture. So basically that is what happens. Now, when it becomes a client server architecture, where we often have application programs, then the terminal display control, and then the DBMS compilers, and then the operating system, I mean the software, all of those things are concentrated in the centralized database system. Now, some part of them is being moved. For example, some of the computers can be, as we said, suppose this is a computer, This is our network. Okay, some of them can still remain only client. Sorry. Some of them can still be clients, and some of them can be, for example, in order to share printer, one can become print server. In order to share files, if someone becomes file server. Then in order to share access to the DBMS, some of them can become DBMS server, and yet still we can also have things like a web server and so on. So these may be clients, okay? These are still clients, or these can be servers which are having distributed responsible processing. Given separate processing. For example, this is a print server. They are all servers. Okay, they are all servers, or they can also act as client at the same time, but they also perform the job of a server. So that is, and they are connected, as we said, they are connected in a network. Okay, it may be a local area network, or it may be a wide area network. So they are connected through a network. Now there are many different types of architecture, but what is the present scenario, how the DBMS architecture have moved from, has evolved. Today we have this client server architecture is, for example, you have a client here, then you have the interface. Okay, usually web interface. Earlier, it used to be GUI. This was very common. That is, graphical user interface was very common. Then you have application server, or you have a web server where you have the application programs, and you have the web pages. Then you also have this database server. So where you have database management system. Oh, sorry. So this is what the modern day client server would look like. So at the client side, you have the web interface, which usually, when you the web interface, you are able to access through web browsers. Okay. Earlier, it used to be graphical user interface, which needs to be installed. Okay. A small program to display on the client side needs to be installed, and then only through this user interface you can start accessing it, because it will give you all the interface which is necessary to access this database system. But now that necessity to install multiple programs. For example, you are accessing 100 websites. Most probably that will be, you are accessing 100 database system. Sorry, 100 database system. So then if you have to install the graphical user interface, you have to install hundreds of them. So that becomes too much for one person, because the number of access we have to the websites or the database system is increasing. Almost every website that we are accessing is based on a database system. So if all of them ask us to install a small program, then after accessing 100 websites, our computers will be full of this small programs that is necessary to interface. Now, what happens is that most of them are web-enabled, web interface. So you can simply access them through your web browsers like Chrome or Firefox and so on. So by using those things from the client side, you can simply access the database system. Now, in order to access those database systems, you have to go through certain servers, application servers, or if it is a web pages that you are accessing, it will be probably a web server. So these things allows you or enable you to access the database system, which is stored in a database server. As you can see, we have two different types of server. Just like this is the gate through which we have to pass through, then we actually come to the database server. Now, if you notice that when you are accessing some websites or online purchase, or which is most popular, most probably, so you have to create a username and password. Okay, so the web browsers send a request, and then accordingly this will process, the web server or application server will process where you are allowed to your login credentials are checked and so on. Once all of those things are true, then you will be accessing the database system. So as you can see that in this simple three-tier client-server architecture, from a centralized system where everything is concentrated in one place, now it has come a long way. There are different ways the architectures can be organized. We are just giving you some of the examples through which this client-server architecture may be designed. So we have explained the three-schema architecture using, we have explained the the database architecture using the three-schema architecture, and using the same three-schema architecture, we have also explained what is the data independence, or what is logical and physical data independence. Then finally, we have explained how the database system followed the evolution of the computer architecture, and it started from a centralized database management system to a client-server database management system. With this, we have come to the end of today's class. Thank you very much.